I don't need it. So own circle, you should have your own radius. So here's the question I have for you guys. How many of your radii do you think you could fit around the circle? So look at your radii right now and try to, I don't know if you want to just maybe put, the ends of your fingers on it and try to go around the circle, but see how many radii you think you could put around your circle. All right, it's not going to be exact because you just freehanded a circle, which is fine. How many of your radii do you think you could fit around the circle? Anybody come up with some guesses? You want to just throw out there, Saad? 6? Well, just here you go. Let me take my big circle right here. I drew my radii in. I'm starting to. How many of them could I fit around until the end? Okay, because I don't want them to overlap anymore. Wherever I started, that's where I want to end. Okay? Believe it or not, hey, the answer is the same for everybody in this room. The answer is the same. Take a look at my big circle up here. I drew in this radius. Here's how many I can fit. Everyone ready? You can count with me if you'd like. 1 radii, 2, 3, 4, 5, 6, and a little more. I couldn't fit a full radii in. All right, so I could do 6 and a little more. 6 and change, I call it. 6 and change. What's the formula for circumference again? 2 pi r. Everyone have a calculator with them? Can you please find me the full decimal equivalent of 2 pi? And it comes out to be 6 and change. Okay? That's where that comes from because you can fit 6 and a little more radii around any circle. All right? Around any circle, you can fit 6 and a little more. All right? So that's why the circumference formula is 2 pi r. That's where it comes from. All right? Because you take any radius in a circle, you can fit 6 of them and a little more around the circle. I don't know if you find that neat or not, but decided to show it to you anyway. Okay, everyone good? 2 units ago, we did a big unit on sine, cosine, tangent. And every day I would always start off, make sure your calculator is in what mode? Degree mode. Did you ever think about that thing next to it? Radians, because we're going to talk about it today. There are 2 ways. Your entire mathematical career, you've been measuring an angle one and only one way, and that's in degrees. There's another way to measure an angle, and that's in what's called a radian. Okay? A radian. If an angle is 60 degrees, that means it's so many radians. If an angle is 80 degrees, it's equivalent to so many radians. Today, what we're going to do is start working in radians and degrees. Okay, I'm going to introduce you to this new concept of radians. Right? So how is a radian formed? All right, how do I get these radians? Real quickly, let me just show you the, not history, but the background behind where a radian comes from. Remember talking about arc length yesterday? When the arc length matches the radius length, that is 1 radian. 1 radian. When the arc length matches the radius length, I have 1 radian for an angle measure on the central angle. Okay? Well, what if, you tell me now. Let's say my arc length is 6 inches and my radius is 3 inches. I won't create 1 radian, I'll create 2 radians. All right, so this angle would be 2 radians. And then I'll do 1 more here. "36 inches, 6 inches for the radius." How many radians do you think are created? 6 radians, which is so many degrees, which we'll find out in a minute how to convert. So that's how, I just wanted to show you a little background on how a radian is formed. It's when the arc length and radius have the same length. Arc length and radius have the same length, a radian is created. Here's our goal today. Go back and forth. Degrees to radians, radians to degrees. Angle's 30 degrees. An angle is 30 degrees. How many radians is that going to be then? Another way to express the angle. Everyone, take your formula sheet that you got as you walked in today. We are going from degrees to radians. So everybody take a look in that second column. Does everyone see where it says degree equals radians? And there's certain numbers there. Does everyone see that? Degree equals radians. I'm starting with degrees and I want to go to radians. 1 degree equals how many radians? Pi over 180. So if we want to convert degrees to radians, we multiply by pi over 180. And that conversion will always be given to you. Degrees to radians multiplied by pi over 180. So let me take this slow now. If you want to convert 30 degrees into radians, I take 30, the degree measure I was given, and you multiply it by the conversion, which is, ready? Pi over 180. Hold on, don't touch the calculators yet. I do not want, you know how I feel here. I don't want this long strand of decimals. When you write an angle in radians, keep the pi there, please. All right, radians are usually written in terms of pi. So this would be, oh, do you see any equal sign, by the way? Anybody see any equal sign in between here? Me neither, so don't cross multiply. 30 times pi over 180. Keep the pi in your answer. Keep it in terms of pi. I am going to ask that you reduce that, though. Reduce the fraction. And what's 30 over 180 reduced down to? Here you go, 24. What's it reduced down to? Pi over 6. So let me just slow down here. So if an angle is 30 degrees, that means it's about half a radian. Okay? 30 degrees is about 1/2 of a radian. Right? But do I want to write all this? No, that's why I keep the pi there. Okay, but I'm just trying to have you guys visualize that 30 degrees is about half a radian. Okay? All right, what about 45 degrees now? 45 degrees. How many radians are in 45 degrees? So I take that 45, multiply it by the conversion, pi over 180. So 45 pi over 180. I leave my radians in terms of pi, and I convert 45 over 180 to simplest form. And 15 when you're ready, what's that reduced down to? Pi over, yep, 1 pi over 4 or pi over 4. Yep. Everyone all right? Okay, what about 60 degrees? 60 degrees. How many radians are in 60 degrees? $60 pi over 180. I'm leaving that pi in the answer and reducing it down. What do you got for me? 3? Pi over 3. Nice. And if you want to see actually how many they are, go ahead, do pi over 3 in your calculator. That's how many radians are in 60 degrees. And then finally, 90. And that reduces down to, what do you got for me, 2? Pi over 2. Yep. Okay. Yes, son.
So, like, what's the point of a radian? Like, why does it exist?
Because there are only certain things that you can do with circles and other things as well, which you'll get to next year, that you can only do in radians. Like if an angle's in degrees, some things you can't do. You need it in radians to, or like I'm going to show you Monday, I'm going to show you a formula, a new formula to find arc length, but you can only use that formula if the angle's in radians. Mm-hmm. Okay. Because remember, here you go. I'll just show you a little sneak peek. I'm sure everyone's excited as I am. You remember our arc length formula from yesterday? How did it start out? Measure of the arc over 360, but that measure's got to be in. Okay, but what if it's on Monday? What if it's in radians? That formula's no good anymore. So that's why I got to show you a new formula if the angle's in radians instead. And this is actually how you graph sine, cosine, tangent next year's in radians, not in degrees. Okay? It's my best explanation for you. It is useful, yes. Okay, backwards now. What if it's in radians and I want you to go to degrees? Well, it's not going to be pi over 180. Everyone take a look on your formula sheet. Everyone see now where it says radians equals degrees. Not pi over 180, but I'm going to multiply by, what's it on the formula sheet? 180 over pi. And you'll see real quick why I need that pi on the bottom in the denominator. So if you have an angle of 7 pi over 6 radians, an angle of 7 pi over 6 radians, what is it in degrees? Do you see what? Anybody know why you need that pi in the denominator? Because it's going to cancel out. Yeah, that's why that pi goes on the bottom. All right, so they'll cancel each other out. And no equal sign, do not cross multiply. You're left with 7 times 180 all over 6. And that'll be an angle measure of, bless you, 210 degrees. So 7 pi over 6 radians is equivalent to 210 degrees. And then you guys are kind of going through, looks like 6 and 7 on your own. You may have a little hiccup on 8, but we'll get there. So times 180 over pi. Six and 7, just 6. What'd you get for the degree measure? 6. Look at that. 108. Nice job. And then 5. If I have 5 pi over 3 in radians, how many degrees do I actually have? Here you go. 28. 300. And does anybody see anything different in number 8? 3 radians into degrees. Anybody see a little something different? I'm not looking for anything complex here. What's missing? Well, fraction, and there's no pi with it. Radians don't have to come with pi's. All right, it's just 3 radians. There you go, 3 radians. It's in radians, so what am I going to multiply it by? 180 over pi, but guess what's not canceling out now? The pi. Okay, the pi is not going to cancel out. Don't put a pi with the 3. All right. The pi's aren't canceling out, so you multiply the 2 right in your calculator. And can you get, let's go nearest tenth for this. So 3 radians is about how many degrees? Nearest tenth. And I'm still not done after this. 24? About 171.9 degrees in 3 radians. Add a number 9 somewhere. 1 radian. 1 radian. About to the nearest tenth. Nearest tenth. 1 radian, about how many degrees? 5? Okay, 57.3. Hold on. And sorry, some of you like it, but I know some of you don't, but this is why you're in honors here. Go back to my conversation with you at the beginning of class. How is 1 radian created? On a circle, when is 1 radian created? Saad? Arc length and radius are the same, so give me a values of each. 5 and 5? We already know because these are the same, that should be 1 radian, right? Okay, use your arc length formula. Can you find out how many degrees are in that angle? Can you find out how many degrees are in that angle? I'll do it with you. Ready? 5 equals, bless you, measure of the arc. Do we know the measure? No, that's what we're trying to find because remember, the measure equals the central angle. Over 360 times pi d. Pi times 10. Okay, help me solve for x. You guys did this for homework. 5 equals x over 360 times 10 pi. What are you guys multiplying both sides by? 360. I'm just proving a point here. So I have 360 times 5, 1800 equals 10 pi, x, 10 pi times x. What are you guys dividing both sides by? 10 pi. I'll do it up here on the big screen for the big reveal. Oh, 57.3 degrees. Okay, that's how 1 radian. Okay, when the arc length matches the radius, 1 radian, which we just found out was 57.3 degrees, 2 different ways. All right, questions? Okay, you're probably going to fly through the homework, which is fine. When you get to number 9, talk with each other here. Talk with each other with number 9 because I do not want to try to, I know this sounds bad as a teacher, but I don't want to try to help you out. I want you to try to grind it out with somebody around you or a friend in the class if you have any friends. Okay, so go ahead, start it up.